morning, children. In today's class we shall see how to solve linear equations in 2 or 3 variables using matrix method. Now matrix method basically means using matrices and concepts of matrices to solve linear equations. Solving linear equations by matrix method. So to solve linear equations by matrix method, we first need to take an example and understand. Suppose we have linear equations in 2 variables expressed in this form. Now since we are using the matrix method, we'll convert this equation into a matrix equation where in the first matrix we write down the coefficients of x and y of both the equations. The next matrix is a matrix of variables, and on the right side we have the matrix of constants. So you can see here that this is a 2 by 2 matrix, this is a 2 by 1 matrix, and matrix multiplication is easily possible, and the resultant is a 2 by 1 matrix. Let us name these matrices as matrix A multiplied by matrix X, which is equal to matrix B. So we are trying to find out here matrix X, because if we know matrix X, that means we know the unknown variables X and Y. So let us pre-multiply the matrix equation by A inverse. So we obtain A inverse into AX is A inverse into B. Because matrix multiplication is associative, the equation can be written this way, and a matrix multiplied by its inverse will always give identity matrix, and identity matrix multiplied by any matrix will be the matrix itself. So this is how we can find out here matrix X. That means we need to find out A inverse and we need to find out B. Now here we also know that A inverse can be found using concepts of matrices, like we know how to find out adjoint of the matrix, we know how to find determinant of the matrix, and dividing these two or multiplying adjoint of a matrix by the scalar quantity 1 upon determinant A, we obtain the inverse of the matrix. So inverse of the matrix when multiplied by matrix B will easily give us matrix A. Now here certain cases arise. First case, determinant A is not 0. Here is determinant A. If determinant A is not 0, then this means that the equations, the pair of equations or the set of equations have unique solution. If the equations have unique solution, then this also means that the equations are consistent. Since there is a unique solution, that means there is exactly one value of variable x, one value of variable y that will satisfy both the equations simultaneously. There can be a situation where determinant A is equal to 0. If determinant A is equal to 0, then in that case you know A inverse cannot be found because denominator is 0, that means A inverse is not defined. A inverse is not defined, that means x cannot be found. So what is to be done in that case? Whenever determinant A turns out to be 0, there are two possibilities. The equations have many solutions, or a second situation where we can say that the equations have no solution. So how do we know what kind of solution will the equation have in case determinant A turns out to be 0? we will find out here adjoint of A, multiply it by matrix B. If this product turns out to be a zero matrix, the equations have many solutions, and in this case also we say that the equations are consistent. Consistency word basically means equations have solutions. Either they have a unique solution or they have many solutions. In this case, if we find out adjoint of A and multiply it by matrix B, we will see this is not equal to the zero matrix. In that case, we can say that the equations are inconsistent. Let's take an example and quickly understand all the three cases. So the first example, I'm writing this side. Suppose our equation is x plus 2y equal to 3, 3x plus 4y equal to 5. Then from here, you know matrix A is this matrix, and when you find out its determinant, it turns out to be -2. Now determinant is not 0, so in this case we know it is a unique solution, right? You can also find out here a concept that you've done in previous classes. Compare this ratio, which is 1/3, and this ratio, which in simplified form is 1/2. The two ratios are not equal, so that means the equations have unique solution. For this case, let us have an equation. X plus 2y is 3, 2x plus 4y is 6. Now from our previous knowledge, if we compare the ratios, the first ratio is 1/2, the next ratio and the third ratio are all equal. So if all the three ratios are equal, we know there are many solutions. Okay, and in this case, suppose our equations are x plus 2y equal to 3, 2x plus 4y is equal to 5. Comparing the ratios, the first ratio 1/2, second ratio 1/2, the third ratio 3/5, and we come to this situation which basically tells us that the equations have no solution. So the same concept we are finding out using matrices, concepts of matrices, which is adjoint of matrix, then multiplication of matrix, right? Now here, if the equations are inconsistent, there is no solution, so obviously we can't find out the solutions. Here, if there are many solutions, we can find out all the solutions of the equations, but this portion, according to the CBSE guidelines, is not in the syllabus. So what exactly is in our syllabus is this particular case. Equations will have unique solution, and then we can find out the unique solution. How do we find the unique solution? Using this. Find out the inverse of matrix and then find out the matrix X. Hence we are able to obtain the variables X and Y. So now we are going to use these concepts to solve questions from exercise 4.6. Exercise 4.6. So classify the following system of equations as consistent or inconsistent. So I picked up three questions from here. The first question, a pair of linear equations is given. X plus 2y is 2, 2x plus 3y is 3. So the first step, convert the equations into matrix notation. Coefficients of x and y, matrix with variables, and a matrix with constants on the right hand side. So this is like ax equal to b. Find out determinant A. Determinant A is -1, and since determinant A is not 0, we know that equations, the given equations, have a unique solution, and because the equations have unique solution, this means that the equations are consistent. So these are questions usually asked in exam for 2 marks. Okay, then next I'm going to take up here question number 3. The equations are x plus 3y is 5 and 2x plus 6y is 8. So the first matrix is this xy. This is matrix B. So when we find out the determinant, it turns out to be 0. The moment we get 0, the next step is to find out the product of adjoint A and B. Because it's a 2 by 2 matrix, we can directly find out its adjoint, interchange diagonal elements, change signs of off diagonal elements, multiply by matrix B and find the product. So that is 30 minus 24. Next is minus 10 plus 8. So we get here 6 minus 2. And obviously this is not a zero matrix. So since adjoint A into B is not a zero matrix, therefore we can say the equations have no solution at all. Equations have no solution, that means equations are inconsistent. Okay, then next we try out question number 4. 3 linear equations are given. X plus y plus z is 1. 2x plus 3y plus 2z is 2. Ax plus ay plus 2az is 4. Now if we have 3 linear equations, then also we can write down a 3 by 3 matrix. So from the first equation, coefficients of x, y, z. Likewise from the second equation and from the third equation, multiplied by a matrix which has variables x, y, z, and the right side matrix of constants. So we have written the equation Ax equal to B. We'll find out here determinant. Because there are 3 ones here, if you think that you want to use properties of determinants and convert any of these 2 ones into zeros, you're most welcome to do it. As of now, I'm straight away going to expand it along the first row, keeping in mind that this element will change its sign. So 1 multiplied by 6a minus 2a minus 1 into 4a minus 2a plus 1 into 2a minus 3a. So 4a minus 2a minus a, this value turns out to be a. Now here there are 2 different cases. First case, a is a constant, it's a real number if a is equal to 0. Or let's start with a is not equal to 0. If a is not equal to 0, then this means that determinant a is not 0. Determinant a is not 0, so these equations have unique solution, and in that case equations are consistent. Case 2, if a is equal to 0, if a is equal to 0, that means determinant a is 0. Now if determinant a is 0, now let us see what happens. A is 0. Look into the third equation. This is the third equation. If a is 0, that means the third equation does not exist. What are we left with? Is only 2 equations. 2 equations have got 3 unknown constants. And we know from our previous knowledge that if we have to find out 3 unknowns, we should have 3 conditions. But in the present scenario, the moment a is 0, we get to know that x and y, values of x, y, z cannot be found from only 2 given equations. So if a is equal to 0, in that case we say equations are inconsistent. The equations basically cannot be solved. Equations cannot be solved, there is no solution, hence equations are inconsistent. So now we have the second set of questions which says solve the following system of linear equations using matrix method. Okay, so here let's start with question number 9. Linear equations 4x minus 3y is equal to 3. 3x minus 5y is 7. So 4 minus 3, 3 minus 5, matrix X and matrix B. So first step, find determinant. It is minus 20 minus of minus 9, so minus 20 plus 9 minus 11. Since determinant A is not 0, so we know the inverse exists. Inverse exists, we can directly find out the inverse because finding adjoint of a 2 by 2 matrix is simple. So if I directly substitute values, this is the determinant 1 upon determinant A, and adjoint of a 2 by 2 matrix minus 5, 4, this is 3, minus 3. So we leave A inverse this way only. Now we also know that our equation is AX equal to B, where we can find out matrix X if we multiply A inverse by B. So matrix X is this, the inverse is given by this result into matrix B, which has elements 3 and 7. So here I have not done the scalar multiplication. If we multiply each element by minus 1 by 11, then we have rational numbers, and simplifying with rational numbers can be slightly difficult. So without performing the scalar multiplication, we are performing this product, finding out this product, which is minus 15 plus 21 and then minus 9 plus 28, which gives us 6, 19. So comparing, because the matrix XY is equal to this matrix, hence value of X is minus 6 by 11 and Y is minus 19 by 11. So these are simple questions, and these questions can be asked in exam for 4 marks. So you have to remember, what are we using in this equation? We are basically using matrix method. This method is mentioned in the question. If this method is not mentioned, these equations can be solved by any method which is known to us from our previous knowledge. So next we'll try our question number 12. Set of 3 equations is given. X minus y plus z is 4. 2x plus y minus 3z is 0, and x plus y plus z is 2. Okay, here whenever we are solving such equations, the moment we find out the solution, we can cross check by substituting it in both equations. If the conditions are satisfied, that means we have found the right solution. So we can cross check as well. Okay, coming back to this question. Coefficients 2, 1, minus 3, 1, 1, 1. Variables x, y, z. And constants 4, 0, 2. So this is Ax equal to B. Let's find out determinant A. Here again there are 3 ones. If you want to convert any 2 of them into zeros, you can do so. As of now, I'm simply expanding along the first row. So that is 1 plus 3 plus 1 into 2 plus 3 plus 1 into 2 minus 1. So we are getting 4 plus 5 plus 1, which is 10. Since determinant A is not 0, so that means A inverse exists. Because A inverse exists, we proceed to find out A inverse, and now we'll find out the adjoint of the matrix first. So here I'll again circle these elements. These are special elements. So finding out the cofactors here, this is 4, this will be 2 plus 3, 5, so minus 5, and this is 2 minus 1, 1. Next here it is minus 1, minus 1, minus 2, changing sign, plus 2. Here it is 1 minus 1, 0. For this it will be 1 plus 1, 2, changing sign, it's minus 2. Then here it is 3 minus 1, 2. For this element, minus 3, minus 2, minus 5, and result is 5. For this it is 1 plus 2, 3. And then finding out its transpose. 4 minus 5, 1, 2, 0, minus 2, 2, 5, 3. Okay, so we have got the adjoint of the matrix, and next step, we will find out the inverse. The equation is this, which implies that X is A inverse into B. So the matrix equation is XYZ. Here again, inverse we know is adjoint upon A. So the determinant is 1 by 10 into the adjoint, which is this. Multiplied by matrix B, which has elements 4, 0, 2. Here again, please remember, we are not performing the scalar multiplication first. We will multiply the matrices and then we will multiply each element by 1 by 10. So here we get 16 plus 0 plus 4. Next, minus 20 plus 0 plus 10. Then 4 plus 0 plus 6. So after simplification we get here 2 is minus 1 and 1, and the matrix XYZ is equal to this matrix. So using concept of equality of matrix, we get X as 2, Y as minus 1, Z as 1. This is the final answer we have got. You can always cross check by substituting values here. So if we substitute, let's check in the first equation, 2 plus 1, 3 plus 1, 4. This equation satisfied. Next, here it is 4 minus 1, 3, minus 3, 0. This is also satisfied. Over here, 1 plus 1, 2, satisfied. All equations satisfied, so we have found the correct result. If you do not cross check, then in case there is an error, you will not be able to find it out. These kinds of questions where we have got 3 linear equations, these questions are usually asked in exam for 6 marks. Alright, now similar kind of question, question number 15. So next we are solving 15th question. In the 15th question, a 3 by 3 matrix is given. First row, second row is 3, 2, minus 4, 1, 1, minus 2. We are asked to find out A inverse. So this is the first part of the question. And then using this A inverse, solve these equations. So 2x minus 3y plus 5z is 11. 3x plus 2y minus 4z is minus 5. X plus y minus 2z is minus 3. Now in this question, the first part is find A inverse. So we will find out this, and then we'll use A inverse to solve this. We'll directly not start solving these equations. Okay. So to find out A inverse, let us first of all find out the determinant and expanding once again along the first row. So 2 into minus 4 plus 4 plus 3 into minus 6 plus 4 plus 5 into 3 minus 2. So this is 0 minus 2 minus 6 plus 5. Determinant is minus 1. So since determinant A is not 0, so A inverse exists. So we have right now simply checked that A inverse exists. Now we'll find out A inverse. So for this we need to find the adjoint of the matrix. So you know we first find out cofactors and then we transpose them. So once again, circling these special elements. I usually circle these elements just to remind myself that the signs for these elements will change. So for this element it is minus 4 plus 4, which is 0. For this element it should be minus 6 plus 4 minus 2, and hence it is plus 2, and 3 minus 2, 1. Then over here it is 6 minus 5, 1, so minus 1. This is minus 4 minus 5, minus 9, and here it is 2 plus 3, 5, so minus 5. Next it is 12 minus 10, 2. This is minus 8 minus 15, minus 23, so it will be plus 23. Next is 4 plus 9, 4 plus 9, 13. Okay, and then transpose 0 to 1, minus 1, minus 9, minus 5, 2, 23, 13. So we have got it joined. Now let us find out inverse. Inverse is the determinant, which is negative, into the adjoint, which is this, minus 1, minus 9, minus 5, 2, 23, 13. So since there is a negative sign here, so changing signs inside the matrix. This is what we get. So we have found A inverse. So this step is done. Now we'll use this A inverse to solve the equations. So I'm solving the equations here, converting the equations to the matrix notation first. 2 minus 3, 5, 3, 2, minus 4, 1, 1, minus 2, x, y, z, and constants 11, minus 5, minus 3. So when you write down the matrix equation, look at this matrix and the given matrix here. Each and every element is exactly same. So we know this is matrix A, matrix X, the product is matrix B. So what will be X? The inverse matrix into B, and this inverse matrix we have already found out here. So that's what we substitute here. So we are not finding out the inverse once again because we have already found it out. So 0, 1, minus 2, minus 2, 9, minus 23. This is minus 1, 5, minus 13, multiplied by 11, minus 5, minus 3. So what will we get? So let's multiply 0 minus 5 plus 6. That gives us 1. Then minus 22 minus 45 plus 69. So this is 67. 2 minus 11 minus 25 plus 39, this is 36, and here is 3. So here comparing, we get x is 1, y is 2, and z is 3. So here let us substitute the values in these equations and cross check. So this is a bit of a rough one that we are doing. X is 1, y is 2, and z is 3. So 9 plus 2, 11, first equation satisfied. Next, x plus y minus 12, so this is minus 5, this is also right. Substituting here x plus y minus z, this turns out to be minus 3. So the rough work tells us that these are the right values of x, y, z. So now we are trying out question number 16. This is a word problem. So you should have your book in front of you. I'll read out the question. The cost of 4 kg onions, 3 kg wheat and 2 kg rice is rupees 60. The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. Cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. So find cost of each item per kg by matrix method. So in this equation, onions, wheat, rice, the cost of some quantity of onion, wheat and rice is given. Okay, so let us suppose that the cost of cost of 1 kg of onion, 1 kg of wheat and 1 kg of rice be rupees x, y, z respectively. So the question says that the cost of 4 kg onion, so if the cost of 1 kg onion is x rupees, the cost of 4 kg onions would be 4x. 3 kg wheat, cost of 3 kg wheat, 3y. Cost of 2 kg rice, the total cost is rupees 60. So according to the question, we are able to write down this. Then next situation is the cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. And the last situation, the cost of 6 kg onion, 2 kg wheat and 3 kg rice is 70. So what are we finding out here? Cost of per kg of each item. Okay, using matrix method. So let us write down the matrix equation. 4, 3, 2, 2, 4, 6, 6, 2, 3 multiplied by matrix X equal to matrix B. So this is AX equal to B. Let's find out determinant. Again expansion along the first row. So 4 times 12 minus 12 minus 3, 6 minus 36 plus 2, 4 minus 24. So this is 0. Minus 30 into this 90 minus 20 minus 40. So the determinant is turning out to be 50, which is not 0. So we get to know that the inverse exists. Okay, next step, let us find out here the adjoint of this matrix. So here, let's do it this way. And starting from here, the first adjoint is 0, the next adjoint is 6 minus 36 minus 30, so plus 30. Next it will be 4 minus 24 minus 20. For this it is 9 minus 4, 5. And here it will be 12 minus 12, 0. Here is 8 minus 18 minus 10, so plus 10. This is 18 minus 8, 10. This value is 24 minus 4, 20, and hence minus 20. This value is 16 minus 6, 10. And finally finding out its transpose. So we have found out the adjoint matrix. We know the determinant. So next step we'll find out A inverse, which is the adjoint divided by the determinant, and the determinant is 50. This is the adjoint matrix. Here again, we will not do this scalar multiplication, leave it as such, and then since AX is B, so we know X will be A inverse into B. So substituting or writing down the matrices, the inverse matrix multiplied by matrix B. So matrix B is this 60, 90, 70. So once again multiplying the matrices, this is 0 minus 450 plus 700. Next is 1800 plus 0 minus 1400. Next is 1200 plus 900 plus 700. So what is this value equal to? 250, which on further simplification gives us 5. This value is 400, so 8, and this is 16. 400, which is equal to 8. Get to know X. Now here you have to see that what is X? X is cost, and hence it has a unit. So X is simply not 5. X is rupees 5. Y is rupees 8, and Z is also equal to rupees 8. Now these word problems in exams can be asked for 6 marks. And to ensure that you get the correct marks, full 6 marks, whatever answer you've got, please put into these equations and cross check. If these values satisfy all 3 conditions, we have got the right value. If the right values are not obtained, we know before moving on to the next question in the exam, we know we have to redo the question. Somewhere there has been a mistake. So these are all the important questions that we discussed from the exercise, and I hope this will help you to solve the remaining questions of the exercise.